Greetings, this is Eric Andelin, Senior Photogrammetry Workflow Specialist with SimActive, and I'd like to welcome you to our webinar, Mapping Water, Can You Really Do It? And with me today, I have my guest and longtime friend, Austin Scheib, UAS pilot, and somebody who works for a lot of companies. Austin, give us a little bit of your background and what you're doing now.
Thanks, Eric. So I've been flying drones for going on 6 years now. Started off with just simple photography and got into more of the technical side of things with mapping. But now I'm actually into surveying and engineering fields. So we provide a lot of data through drones and including LiDAR, photogrammetry, mosaics to help aid in our projects.
Mm-hmm. So do you have an education in survey? Do you have an education in engineering? Either?
So neither. I am just learn it as I go. So
yep. Well,
yep.
Good for you. You're young. If you want to get one of those, you can.
Yep. Yep.
Go ahead.
I said I got certified with my drone pilot's license and just loved it. I love the technicality of it, the challenges, and just go forward with it. Learn and grow as you go.
Yeah. So primarily, like geographically, where do you work?
Southeast North Carolina, primarily.
Okay.
Yep.
All right. I was gonna say Southwest North Carolina's got a lot of work right now.
Yeah, they've got it pretty bad.
The reason we're talking is it's a common problem that people have, and you kind of brought to light occasions where you're working on projects where there's water in the scene, or maybe that the intent of the project is what's going on with the water or in the water. And that brings up the bigger question for people. Can you map water? Two, can you at least, capture the data in a way that the water will look proper, appropriate, good, whatever you want to call it. And, being that both of us, you're near the coast, I'm near the coast. If you consider that 90% of the population's near the coast, being able to map around or in water is kind of a big deal. So, that's kind of how you and I started this conversation, and you're not the only one. So let's go over our topics. First, we have considerations before flight, then options for successful aerial triangulation, followed by ways to fix DSMs/DTMs, and then finally, solutions to ensure the quality of mosaics. Let's talk about a little bit about considerations before flight. One, you're flying drones primarily. Do you have a drone of choice?
So yeah, for most of these larger scale projects, we fly a Wingtra Gen 1, which is excellent for these projects.
And which camera's in that?
It's a R6 Sony.
Okay. So I'm familiar with that. Now, the challenge for capturing data out into the water is primarily that as you get into water, just as if you were going to go over a solar farm, things for the software to identify become less and less and less. So eventually you've got nothing for the software to create a tie point. And once you get to that point, depending on the software you're using, it'll either just not do it, or it'll make an attempt at it. And that's where the challenge comes from. It really is, it comes down to, especially with drones, the footprint of the image. So clearly, the higher you fly, the bigger the footprint you have, the more opportunity you have to find those tie points. So for example, an aircraft will fly at, 2,800 feet or something like that, and it'll create a big footprint, and then going over a lake is a piece of cake because you're going to have the shoreline on both sides, and therefore tie points can be made and there's no issues. But when you start working with drones, now your footprint's much smaller. So you can mitigate that situation based on how you fly. So, take us through a little bit of the steps you go through before you take on a project such as this.
Yeah, so in every mapping project, we kind of lay the project out and our flight out before we ever even go to the field. If we know we're going to be flying over water, most of the times I'll increase my frontal overlap or side overlap. That way I've got more data per image. Yes, it's going to create a larger data set, but when you're over water, most water that you're flying near is going to have trees and a lot of times dense vegetation. So I'm always kind of the one to get more data, even though you may not need it. And then that way you have a better opportunity to work with it. So I definitely say increasing your overlaps near water is definitely going to help your project, and having more data is going to help your project move forward better.
Absolutely. The beauty of digital cameras is it doesn't cost anything to take a photo. So
That's right.
unlike the old days when it would cost X amount of dollars to take the photo and then $15 to $20 to scan the photo, it became really expensive really fast. And that's probably, the biggest reason that people, ASPRS recommended 60% overlap and 30% side lap, but nobody wanted to do more than that anyway, because it just added expense to the project. And the beauty of having a drone is that capture as much as you can. You can always start throwing images out if you want to speed up processing, or if perhaps it's going to make a better final image. So certainly that's the case. And the other thing you brought up there is another unfortunate truth about water. Typically when you're flying an area with water, you have vegetation around it. Makes absolute sense. You're going to have some kind of tree, some kind of vegetation, on the side of the water, the lake, the whatever. So that creates another challenge when capturing data. You also have things in the water, and those actually can be a help. But so I would assume that you take into consideration direction of flight, or maybe even the pattern that you're going to capture.
Yeah, so one of the biggest things is weather. Obviously, a clear sunny day, you're going to get a lot of reflectivity off the water.
Yes.
And it just, if you're familiar with photographs, it just almost blows the photo out by being overexposed over the water. So you end up with a lot of white pixels, and then the software trying to stitch those together, it just doesn't know what to do with them. And so, the day I'm flying is generally a cloudy, overcast day, and obviously we're flying in lower wind conditions for stable flight, but that one thing, just being overcast, I would say is probably the number one thing I'm looking for.
Yeah, absolutely true. We talk about a lot when we're doing mapping that you want to map within, a certain sun angle because you want to minimize the shadows. But when it comes to water, that works against you. And in fact, you can assume that one direction you fly, you're not going to have as much, solar flare coming back up at you, and the other direction you will. So that's a good reason to have a lot of side lap, because then you can, once you've done the AT, you can eliminate those flight lines and reduce that, the solar glare. So something to certainly consider. It's not common in our brain to say I want to fly it when it's overcast, but it's a great time to do it. Absolutely, that does create challenges. And then so we talked about weather, we talked about the terrain around the lake. We all know that the FAA gets involved if you're anywhere near an airport or any of those things, so those we can leave alone. I mean, do you have any anecdotes of projects that you've worked on where you thought you were doing it right and come back and say, this the way I flew, this isn't going to work out?
Yeah, so I think actually the first project I reached out to you about was actually a boundary survey, and the back portion of the property, that property's deed read the run of the creek.
I remember.
And we planned a flight to go fly it, took off, flight went well, drone landed safely, which is always a plus. And I started processing and noticed that It was a creek, so it's water, and then it's heavily wooded on either side. And being so homogeneous in such a narrow creek, the software really had a hard time tying those images together.
Yep.
Um,
Yeah, I do remember that project. And the one thing I'll say that people should consider, when you're talking about setting up the flight, is that you're right. If you have a creek or something at the edge of the project, you want to make sure that you overfly that quite a bit so that you've got something over there. Because as we'll talk about, all of these tie points go to completing the AT. And from there, you create your surface. If those tie points are bad, or if there's nothing there, the software will try to create a surface, and a lot of times it'll create issues. So it either does that, or depending on what you're using, it just says, I'm not making anything over there, and it just leaves you a hole. So that brings us to our next topic, options for successful aerial triangulation. Now, I know you have a data set, and we'll take a look at that later. But it brings up some of the things you can do in tie point production. So what happens is you want the software to be able to look at the same pixel in as many images as possible so that it can correlate that, correlator 3D, and create elevations based off of that. So the challenge becomes, again, as I said, when you get near water, is that they can either be distorted, left out completely, things like that. And you can just say, I'll take that and I'll work with it. But you can also go into the software and manually add tie points. And I should back up one step. It does an automatic tie point search, but it also has a robust tie point search. So if what you're getting in your results are not so great, you could run the exhaustive search, and it will probably find more tie points. But even then, you're most likely, especially around water, going to need to get tie points manually. When you're over water, sometimes there's things in the water that you can create tie points from. And in your project, you're talking about keeping track of algae or water-based vegetation that's encroaching on that lake or that pond. And that's what you're monitoring, because you want to see how much over time that encroachment occurs. And in Florida here, we have, fish kills from red tides and things like that. Red tides are caused by algae blooms. So if you can monitor those algae blooms over the lake, that's a good thing. But again, the software doesn't necessarily reach into there to do that. It's not as good as the human eye. And I know I have created tie points off the top of alligators, off the top of turtles, off of saurum, which is seaweed. I've actually done it off of wave breaks. Anything you can to keep tie points out there so that it will reach out into the water. And what have you run across when it comes to something like that?
Yeah, so to back up to your AT point, whenever you fly these projects and you have the bank or the woods or whatever, you're going to get really good tie points with SimActive through there. But then you're going to start seeing holes where you're over water and it couldn't match and tie it in. So what I always do is, when I'm flying over water, I just skip the standard process and I always run exhaustive, because it's going to save me time in the long run. I've just learned that over doing so many of these projects that I might as well go ahead and the exhaustive is going to take a little bit more time because it's looking harder for those tie points, but it's going to save me time in the long run. So I always run exhaustive. And then where I don't have good tie points, I go in and I'm looking for things like you said, and I think I said it earlier, but a dead tree, a lily pad, it may be a log or a branch hanging over the water that is, I can clearly see, okay, it looks white in the image, or it's a wide out branch. I use those a lot. Just something I could easily pick up with my eye and go to the next image and say, oh, there's the same thing again, and repeat it and repeat it and repeat it. And eventually, it takes some time, but you'll be surprised how many you can find. even in a very homogeneous images.
Yeah, you're absolutely right. You can certainly find information in there that will help you hold together the AT solution. Um, so that that kind of covers that. And again, in your project, you're talking about a lake, and some of the projects that I've worked on, it's the ocean. So in the ocean, you're flying, parallel to the beach, and each line that gets farther out there, the less likely you are to be able to use it. Now, if you have, the fortune of clear water, sometimes, even in rivers, sometimes you can find things underwater that you can tie to. Here we have seagrass, so you can always run out there and pick points in the seagrass, and that'll help you out. But what all this comes down to is it comes down to allowing the software to create a surface. So if you have a surface over a lake, odds are that what it's gonna look like is the surface is diving to infinity, because it doesn't know where to actually close the loop. So you have options there, and you have them in DSM production, and you have them in DSM editing, and that's bringing in polygons of those lake areas and basically replacing what the software created in the DSM with that polygon of information. Now, in some cases, the software will go all the way to the shoreline, and then it starts to lose things out in the water. Well, if you can take a measurement of the shoreline and you've got a polygon of the lake, then you can just bring in that polygon, set the elevation to it, and then tell it to replace that whole thing, and it will fill it in. So that's one option. And you can do it with more than one polygon. So, and if you have, for example, if you pulled that from a LiDAR surface, you may be able to just merge the two data sets and fill the water where you want to fill it. So there's all kinds of ways to do that. And I imagine at this point, you've worked with some of those.
Yeah, so when we reset on that first project, it was you that recommended pulling in a 1 or 2 foot DEM model, and basically just letting the software use that to then create your surface and lay your mosaics and orthos on top of it. And since then, we've actually got a LiDAR drone that we've been using for topo.
Yeah.
And it outputs a 1 foot grid topo output. And so a lot of times I'll even take that out of the process from the LiDAR side and throw it into my projects just to almost skip that step in SimActive.
Yep.
Just by loading that LiDAR in there, let it create the surface off of that LiDAR model, and then continue on with the process.
Yeah. Now, one thing users have to be aware of is it's all well and good when you create your own LiDAR surface and you have your own equipment, because then
Yep.
you've flown it to a certain amount of accuracy. But if you just pull something off of, USGS or NOAA's website, make sure that you look at the metadata to determine, is it going to meet the your needs and the accuracy requirement. Now, again, it's a lake, so you're not using it necessarily for construction grade work, but you still want to know that your shoreline is actually your shoreline and things like that. Yeah.
Yeah. So whenever I go fly these projects, I always get a water elevation, like you're saying, from GPS. And I can always, if I've shot it on either side of the lake, it's normally pretty close because we're not going that far.
Yep.
But I can basically draw that polyline in, or like you said, pull it from another resource and then set it to that elevation. A lot of these projects we're doing near or over the water, we're not really having to use elevation data. It's more or less, just to get the image. But yeah, you're right. You do have to be very careful about what data you're pulling in if you're turning around to throw this out for construction or surveying.
Yeah. And sometimes it's, like we said, it's not one area of water. It may be multiple areas of water. Maybe your whole project is surrounded by water. We've mapped islands, or we've got customer that maps islands. And, to go from island to island, you have to have some kind of elevation in between. So they'll they can either bring in a false surface, They can bring in, like you said, hydrographic information, all that kind of stuff. So in Correlator 3D, you can always bring that stuff in. In fact, if you had, a surface where you went out and you created soundings of the lake, you could always bring that in, and replace what's there with that. I don't know how well your ortho would look afterwards because it would dive in, but if it's not deep, hey, it's not deep. So we talked about polygons and editing and ways to do it. And again, in the demo, I will show options for you when you run into that issue. But the last thing we want to talk about, and that is improving the quality of your mosaics. You create the orthos, and then you create the mosaic. And a lot of times, like I said, if you've got high degree of overlap and high degree of side lap, but yet you have sun beating down on your image, you're going to have a lot of blind spots in that ortho, or it's going to look like, just a bunch of series of white dots, depending on the direction of the flight line and things like that. And you've run across things like this. Yeah.
Yeah, I have. It's, I flew, basically this is like a 900-acre lake, and I basically just flew the coves where the water was shallower. Some of them turned out great with the sun angle, and some of them I had to fly at a different angle for certain reasons. But yes, there's always, that angle is very hard to judge on the ground until you actually get your data set back and look at it. But yeah, there were some images that were almost just completely blown out from being over the water, especially only flying up to 375, max of 400 feet.
Yep. So there's some things you can do in Correlator 3D to mitigate this or to improve your mosaics. And again, if you've flown it with a high amount of overlap, the first thing I would recommend is disabling either flight lines or specific orthos when you create your mosaic. Because the fewer images there are that go over that water, the less chance you're going to have of solar glare. So that is certainly one way to do it. And we've also created an ortho patch tool now in the mosaic editing that you could actually go in and just wipe out some of those sunspots. Just take, select that image and say, right here, I'm getting a lot of solar glare from these images, but now I'm going to cycle through them and I'm going to find the one that's good and use that instead of the others. And you can literally just crop it in. Again, we're talking about water, and in most cases, what's in the water doesn't matter. But in some, like the project you're working on, where you're, again, looking at vegetation in the water, it does matter. So you have to be careful when you do that. And then have you run across that? Have you used that in, I think this...
I have not used that feature actually yet. Yeah. So
okay.
Well, jump on there and learn it myself.
Yeah. With the demo, you'll learn something there, and it's an update that came about earlier this year. So, and it ironically, a lot of the times I was testing the update, that's where I was over a golf course over water, so that was a good place to check it out. We've covered everything. So, I mean, do you have any questions or comments or wisdom for other drone operators?
Just do your due diligence. Like I said earlier, these projects over water are going to take some more time. You're not going to be able to rush through them, as if you were just flying over regular terrain. So just plan for the extra time and, increase your overlaps. Having an RTK drone and base station would also help you as well. If you have GPS equipment, being able to get some of those elevations of the water body that you're working around will help you later through your processing in SimActive.
Yeah.
And just be prepared to spend a little bit more time on those projects.
Yeah, you actually brought up a good point, and I just did a webinar on RTK and PPK and are they of value, and GPS points and all that. RTK and PPK actually work out pretty good over water because they do give you an initial XYZ position for the images, and you can tell the software not to move them. And therefore, they tend to hold tighter the farther you get out into water. So that's one reason to have it, for sure.
Yeah. Well, on a typical project too, even though we're using an RTK drone, I always still like to throw out ground control and shoot them. Just as again, it's just extra data, just another check. And in instances like that, you're not getting any ground control. Now, there were some instances where I could lay something out in an open field right next to this lake,
Yeah.
and shoot a ground control and actually use it. But on my last one of this pond, there was no way to get on either side of it.
Yeah.
There was just no cleared access. So the RTK definitely helps. And like you said, being able to hold those positions in SimActive processing definitely helps.
Yeah. And spoiler alert from the webinar, you do need GPS points. You do need ground control points. Good luck without them, but you do need them. So that's unrelated to lakes and all that stuff, but I'm sure you're familiar with that. So, I mean, Austin, from here, I'll go ahead and do a demo and kind of like show all of the things that we talked about and how you could use those to mitigate flying over water. So I don't want to hold you up for that. I appreciate your time. I thank you for joining us. Thanks a lot.
Yes, sir. I appreciate it.
Very cool. Okay, so let's get a demo project up and running. Let me get it loaded in Correlator 3D, and here we go. So here we have Austin's project, and you can see I can turn off the tie points, and here you can see we've got the end of a lake, and we are going to try and do our best with the software to map this area, taking into account the water. So the first thing you do is you go into AT, and as you're performing your AT steps, you have tie points will be the first things that come up, and you can run standard or exhaustive. So now here I've run standard so that you can see what it looks like. We've got the images, and we'll look at the links. So here are the links, and you can see clearly there's areas where we don't necessarily have good tie points. And you would expect this. This is especially over dense vegetation. You can see this here, you can see it here. And you can also see a couple areas here where we're over water, where we have that issue as well. Now again, we ran the standard tie points. So what I will do is I will rerun it here in just a second with the exhaustive, and we could see how many more points or how many more ties we have collected in between images. Now, I do want to point out that when Austin flew this, he flew this with, a RTK PPK solution. So we do know that the images are in the right location. We could use RTK PPK assisted for this project, and it does help when you're over water. So what we're going to do is we'll run the exhaustive tie points, and we'll see what the difference is. And then we'll also look at how we can add manual points to strengthen that solution before we run the AT. So give me a moment here, and I will run exhaustive. So we'll go ahead and turn these off, go here, and we go to exhaustive. Now we'll go ahead and let that process, and we're off and running. Okay, now that we have our exhaustive tie points run, let's go ahead and take a look at those. And we can see the links. So looking better. And we can now go in and add ties manually if we'd like as well. So let me zoom into an area here, and we'll just go over here and go ahead and turn off the magnification. And the next thing we want to do is we want to add some tie points in here, because if we ran the AT at this point, it is going to have issues in this area. So anything we can do to clean it up, make it look nicer, we're going to go with it. Now, I did mention that this was run RTK PPK, so the positions are pretty good, but they can always be improved via adding additional tie points. Now, this is clearly a challenging area, and all we want to do is help the software get closer. So let's start to look at some things that we could add tie points to. And, don't be afraid when you start this process to think that you're not going to see stuff, because you will. So for example, right here is a tree. It looks like a log. I'm going to go ahead and grab it, pull it across here, and it's going to zoom in and show us that in full resolution. So yep, here we have a log floating in the water or near the water. I'm going to go ahead and just select those. And I can look for some other things. It looks like we have a point here. It looks like something floating in the water. And you can use things that are floating in the water. So we'll make a connection there. Yep, looks like there's something right there. So we'll go ahead and grab that. And again, we just want to be close. So those are good. You see it shifted the images just a tiny bit. So it is making corrections for us. Now let's look for it. You always want to get at least 3. And, you know, out here in the vegetation, it can be very generic and close. It doesn't have to be right on. So we could pick a spot somewhere in here that looked like it matched. And that's always the challenge. So you're going to dig around in there and you're going to start looking for places where you can find matches. I personally find it better to be along the shoreline to find matches in that area. So say, for example, we have one, looks like we've got some stuff over here. And just pick a broad area and then it will zoom into it and you can say, okay, what do I want to tie to down in here? And there's a nice lily pad right there. If I zoom up, there it is right there. Save and close. Okay, so that creates a tie point. We'll go ahead and close that. And you can see it created the ties there. And we're going to look at, you know, how could we tie, for example, these two together. As you do this, the more you do it, the more common items you'll find in these scenes. So let's go ahead and I'll just zoom in to the point of this. And we know we've already gotten, looks like the lily pad over here. So we're going to go ahead and zoom into that. Because if you can find common tie points in data sets, all the better. So I'm going to go ahead and move this to where it's in a similar position. And it looks like, yep, here's probably the lily pad. So I'll go ahead and grab it and I'll bring it across here. Well, looks like something in the water and it looks familiar. So we're going to go ahead and we're going to go through each image because this is the one I just added. And I'm going to say that's there. And you can see it makes a correction right away. Now we have something here and something here. This is the very edge of the image, but it's usable for tie points. So let's see what we got. Yeah, we got something floating right here in this area. So we'll go ahead and select it. And it's going to make a correction. And then we also have something out here in the water, here and here. Here we go again, another log. So we can use this to tie these together. Again, you want at least 3. You can do more, but 3 is what you want. And what we're trying to do is hold this project together over the water. So let's go ahead and close that. And you can see we've just got multiple tie points in there. Now this one's going to be more challenging because it's all water for the most part. Let's see what we can find here. Right away I can see something right here, which is probably tied to this right here. Yep, looks like we got some vegetation floating in the water, and that's okay. It's a lake. It's probably not floating very fast. It's probably not moving very much, so we can go ahead and use that, and I'll just zoom in on a twig there and use that. So we have that position. Looks like we have something right here, and looking over here, I can tell that we do. So I'm going to go ahead, and I could click on this one, drag it over here. And the software is going to give you that approximation circle to say, yes, I see something here. So this was the one we did in the previous frame and the previous frame. Now we have a new one here. And all we're going to do is bring it into the same area. So we're going to say, that looks like a match. Save and close. Now we can look for one more. We've got a whole bunch of debris over in here, it looks like, in the data set. So, but I also know I have that lily pad. I'm going to grab that lily pad again, because I think that's a good one. And here we go. Same thing. I'm going to go through all of the images across the bottom here to make sure that we're looking at the same thing. And it looks like I'm missing here. So let's find out what we've got. Here it is. It's right here. So that would be the same thing. Save and close. Now the software's got something to work with. And you can see it just started filling in more detailed tie points. I'm not going to bore you with doing all of these. I just wanted to show you this part of it. Now, let's also look at what would happen if we were doing AT. Before we go into AT, let's look at some of the other things that we have here. We do have an existing surface that was brought in or can be brought in. And I'll go ahead and get out of the AT for the moment because all we've done is the bundle so far, and we haven't done the bundle adjustment so far. Let's load an existing surface. So before we start with creating our own surface, we could load an existing one. And we'll go ahead and find that here. Add dem to project, demo data, TIFF. So now we have a TIFF of the surface provided by the state of North Carolina. It's a LiDAR survey. So we've got that and we know it's good data. And I can go ahead and zoom out on the project. Now, of course, we get a much larger tile from, the state, but we can work with that. So let me zoom in right here on the project. And interesting thing, you can just take a look at this now. Again, we have not run the AT. We are just looking at an existing surface. Let me go ahead and turn the magnifying glass off. But as we course through these images, and again, omega kappa phi was brought in from the RTK solution. That one's not that great because it came out of a turn. But as we scroll through these, we can look at they're pretty well lined up, nadir. The positioning's good. So it's nice to have. It's nice to have a surface underneath you when you want to check this stuff out. And let's go ahead and get out of there. I just wanted you to see that we have a surface available. We'll go back into the AT steps and we will run the bundle adjustment for these images. Now, again, what was important here is the lake. So let's not worry about the stuff down here because it's not important at the moment. When we go to do the bundle adjustment, in this case, we have RTK PPK solution. Now we know it's from a drone, so you're not going to run full AT constrained because that, again, requires a precise IMU. That is not what we have in drones. So we'll do RTK PPK assisted. The sensor calibration will leave the software to do. We don't have any ground reference information, so we're just going to go ahead and run it. Okay, so we've got our bundle adjustment run, and it actually looks pretty good. We're green all over the place. Got some blanks, again, where we did not put any tie points, anything like that. But we can look at the results. And here we go. Average projection error is good. Number of points per image is really good. Got RTK PPK assisted, sensor unconstrained. And again, we can see where we started, where we ended up. There is room for adjustment here, but it's a good place to start. And again, no image adjustment going on really. Go ahead, hit OK. And again, we could go in and tighten things up and make them look better, but let's go ahead and run it and see what we get. Now, I've already processed this data set, so let's go ahead and take a look at it from that folder. Let me open that up, and here we are. You would expect good results using an existing surface, especially from LiDAR, where you've eliminated the trees. Everything should work out really well. And it looks like maybe it has. Let's zoom in and take a look. So I'm getting a little suspicious here in the vegetation. You can start looking at things and see matches. So this looks exactly like this. This looks exactly like this. And you can see things like that and you're like, well, there's a lot of duplication going on in here. To the naked eye, you might not realize what's going on, but I can tell you what's going on. Simple solution here, or one reason this is the way it is. And that is that there was no geoid offset accounted for when the project was created. And because of that, it's actually projecting through the surface, creating the orthomosaic tiles and creating the mosaic. So you're seeing all this bad data. So I'll back out, I'll reprocess it with the geoid offset, and I bet we see a lot better results. So that's been done as well. Let me load that and show you. So here we have the mosaic created properly on this surface, having incorporated the geoid offset. And we can go ahead and take a look at it and see how things look different. We zoom in here. We can see now that we don't have the duplication we had before. We've got a solid surface, not a lot of duplication in the water, actually none. And everything looks good. This is how it should look, and it's kind of what you would expect if you had an existing surface. That's best case scenario. So let's talk about what you're going to do if you don't have an existing surface. So if you don't have an existing surface, let's talk about the project. What is the project about? The project is about mapping the shoreline of a lake. So we know elevation doesn't really matter. We're also out in the country, so there's not a lot going on out there. We would want a bare earth surface anyway. So my recommendation would be to, when you're working around water, if you can, don't make a DSM at the highest resolution possible. That's only going to create issues for you. So for example, let's go here to the DSM, and it's going to go ahead and estimate the resolution. It's going to estimate the resolution of the DSM based on the images. And it's going to say, I can give you a 0.225 foot resolution DSM. Great, that's wonderful. And if you're doing construction, awesome. But let's say I want a coarse DSM. It's saying it'll create a DSM at 1 foot. I don't even need that much. I'd say give me a DSM at a resolution of 3 feet, because again, it's just an undulating surface. So let's go ahead and just run that. So here's our DSM at 3.5 feet. It's under the mosaic. I can turn the mosaic off and you can see there it is. Now, if you're curious, this is a DSM at 3.5 feet, and this one here is at 1 foot. So really, you're getting a lot more noise. Yes, it's more detailed, but we're mapping water. So let's go back to the 3.5 foot one. The next step would be you can either create the DTM or you can start your editing. So I'm going to go ahead and just start editing real quick. And we know that this area is going to be the least desirable part because it was out in where images were just over water. So it's hard for the software to hold it together. So we go in and we start doing some editing. For example, I don't know what's going on right here, but let's get rid of it. And we'll just delete that. Yep, so that's gone. And we'll do a couple of these here. Yep, delete that. Now we can draw in, we can use the existing imagery to draw in this area and fill it. So we can go ahead and do that. I'm going to go ahead and put the mosaic back on. And let's draw in that area. So say we just want to go here and put that polygon back in. Granted, you can go in much more detail than this, but this is going to work good enough for what we want to do here. And we also know that we've got some good data down here. So I'm not going to go too crazy in creating this. Granted, you can do a couple things. You can import a shapefile with the water boundaries in it. You could certainly do that. Or you can, again, just draw it in. So we're just going to draw it in. And we're going to say, let's set the elevation of that to, I think we were around 8.5 feet. So let's call it 8.5 feet. And if we go back and turn that off, look at the mosaic. Now we're at 8.5 feet. We're pretty good there. So now if we wanted to, we could probably create the mosaic. But before I do that, let's select the whole thing. And we'll look for any ones that are lower than that. So we'll see if we can find anything below 8.5 feet. Let's say below 8.4 feet. And it's found a few things. We could go ahead and delete those, or we could fill them, we could heal them, whatever we want to do. We've got some options there. So if we just went with delete and fill. And now we see everything's flattened out and we've got a nice lake surface and so forth. But before we continue on creating the DTM and the orthos, why don't we look at the other ways that you can manipulate this data set? For example, rather than just drawing in the lake, we could actually bring a shapefile of the lake in. So let's do that. We'll go back to the DSM. So here we are again. Now let's bring in a shapefile of the lake. Here we have one, and we'll just set a random elevation to it. So the shapefile is in. You can see it here just barely, but the next step would be go into the editing tools again. And this time we're just going to edit by the shape. So we'll go here, say edit selection, make sure that the lake boundary is selected. We're going to edit by selection, and we're just going to set the elevation. So it's going to ask us what the elevation we want is, and we'll just say 8 feet, process, boom. There we go. Now we've got our lake boundary in there if we want to use that. So that's one option. Then, of course, the other option we've already discussed, which is to bring in an existing surface and use it. For example, this one here. So you have those options when it comes to importing and manipulating surfaces for things like water to straighten out so that you can create good orthophotos and then a good mosaic. So our next step then is to create the orthophotos. But before that, let me switch back to the DTM created in Correlated 3D, and I'm going to want to do a little bit of editing and cleanup of that just to tighten up the area we're working with. So we'll go ahead and do that. And all I'm going to do is segment the area a little bit. And we'll save that. Now we'll go ahead and create the orthos. So when we're doing this, again, this is, rural area. We don't need true ortho or anything like that, a constraint file. We always want to run it maximal, which is by default. If you went to optimal, you'd see it drops to 30% overlap. In this case, we'll go with maximal. We don't need to change any of the crop values. And since we're doing this for a demo, I'm just going to raise that to about a foot. So in resolution, just to make it process faster. And here we go. Okay, so now we have our orthos. And before we go into the mosaic process, let's look at some of the things that we're going to be dealing with here. So you can see there is glare in the images down here. You can see that. And let me go back out. And you can also see issues with glare up here. So when you tell the software to go ahead and mosaic it, the first thing it's going to do is color balance the whole project. Now, it takes into account all that white glare in the overall color balance. So if you're okay with that, then just go ahead and process it, and you may see a little bit lighter area in the water, a little bit lighter blue. No problem. You could also then post-edit that in the mosaic editing tools just by moving seam lines and so forth. But before you start, you may want to look at the individual flight lines and say, well, what's going on here? I know I have plenty of overlap. Maybe I can get rid of some of these or withhold them from the overall mosaic. So let's again look at the individual orthos, and they should be in here by flight line. Yep. So we've got flight lines. We can turn them all off. Okay. So now we're just looking at one line at a time. So line 1 looks pretty good. Not much of a problem there. These orthos are kind of fishy, so you might want to look at getting rid of those or withholding them. They would be what? On the other side, so it'd be the first ones. Line 2 looks pretty good. Line 3 looks pretty good. So I'm saying we can get rid of most of flight line 1, in fact. Disable ortho number 1, 2, 3, 4, 5. I'm going to let those go. I don't want those in there, and it'll probably improve my output. So let's look at flight line 2. Flight line 2 looks pretty good. Not much to do there. We'll leave it as is. Let's look at flight line 3. Okay, so flight line 3 looks pretty good. You can see that we're starting to get some light images up here. So this tells us flight line 3 is going from northeast to southwest. And let's just take that one out. I didn't really like the color of that one. Might even take the other one out next to it. Maybe even that one. Let's see what we get there. Okay, and then let's go back and we can look at flight line 4. Flight line 4 looks okay. It's also getting a little bright there. Flight line 5, same thing. Flight line 6, so let's go back to 4. We're definitely going to leave 4 in there. Let's leave 5, 6 out. Because you can see we don't have the glare of the sun directly on the images, so we probably want that. So we're going to leave 4 there. 5, not so bad. You're starting to see that glare at the bottom of 5, right? So let's look at those. Just pull those, okay? Now we're going to go back up and we'll look at flight line 6. 6 has got some glare in them. Really all we can do there is maybe edit those in the mosaic editing tool. 7 looks pretty good. 8, of course, we're not going to worry too much about. 9, we're not too much going to worry about. So I would say line 6, we've got a few in the middle here that are going to lighten things up a bit. I might want to take those out. Let's see where they're at. Now, all the software is doing is withholding these. It's just, you know, something to try, trial and error, see what you get, and see how things come out. Okay, so we have pulled all the ones I want to pull out of there. Okay, we're all back on, and we'll go ahead and run the mosaic. So first thing it's going to do, color balance. And now we have a finished mosaic. And you can see here it looks pretty good, but we do have this white spot right here. So overall, I'm fairly pleased with it. We can zoom in, we can take a look at how things are. You know, the mosaic itself looks really good. We can see what we want to see in the water. We don't see that duplication that I mentioned previously. So all looks pretty good. But we've got some swill here. It looks like from sun or a cloud. And then we've got this beast right here. And again, remember I took out some images, so this might be an artifact of that. So let's zoom out. And we'll go into the mosaic editing tools. Select the block. So it's reading the images, and we could see down here is where my issue is. So maybe I want to just grab this. Actually, let's look at our patch tool and see what we've got. What do we have in this area that I can use? So with our new patch tool, I can just say, okay, let's go through all of these images. That one there looks pretty good. Yep, I definitely like this image. So I'm going to go ahead and take a chunk of that image and put it into the mix here. So what's this going to do? It's going to rebalance, and it's going to add that in. So did a little bit of work there to clean things up. Clearly, I could do more to make that better. So for example, if I wanted to go ahead and do another image, got that option as well. Maybe it could be this one. I could just take a chunk of this, throw it into the mix. And I'm just playing with it here to see what we would get. But you can see that's greatly improved over what was there before. So we do have that ability. Of course, you can just go in and edit seamline. So say, for example, maybe we want to let go of that. Let me go to seamline editing. See what we get out of here. So yeah, if we move this way, probably going to get a better result over here. Move this one, move this one, move this one, So you could do this all day long. Display mosaic, save. And we had a little bit of change there. So there are ways to go in and edit these and make them look a little bit more visually appealing in these areas. But as I said before, I might like that area and just say, I want some of this in here. Let it refresh. And we've got a little bit better area there. I want to look over here because this is looking rough. And that looks much better in that area. So I'm going to go ahead and grab that and throw it into the mix. So there's plenty more to do here, but let's just go ahead and finish this and say we're good. Step out. Also, by the way, there is this new feature here that you can turn your seam lines on and off without being in the actual mosaic. So you could take a look at what's it look like, what's it going to look like, that kind of stuff. So, clearly you could spend a lot more time editing in here, but in general, this looks pretty good. We've got either a whole bunch of sun here or just one image that we could probably pull out and clean that out as well. But the point is to show you that you can edit your mosaics to make the water look better. Clearly, if you didn't care about what was in the water, then you could just take it out to Photoshop and mask it and color it one way, and that would be fine. But in this case, for what Austin is doing, he kind of wants to see what's in the water. So that's, how you would go about doing that. So we've covered how to set up your flight lines to best capture the imagery for processing. Then we talked about the options in AT and how to improve your solution. Then we went over DEMs, how you can import one, how you can create one, how you can edit one, how you can modify it, all of those things. And then finally, the orthomosaic process and how you can turn off images, maybe bright ones, and exclude them, then process the mosaic, and then in the mosaic to also be able to go in and edit seam lines and patch and so forth. So with that, we can conclude the demo. Once again, I'd like to thank my guest, Austin. Thank you. I'd also like to thank those of you that attended this webinar. Again, if you submitted a question during the webinar, I'll make sure to get those answered for you as soon as possible. I'd also like to remind everyone that this webinar, as well as all of our previous webinars, are available on our website, simactive.com, where they can be found under the Learning tab. Additionally, this webinar will be converted to a podcast and made available in the next few days. Thanks for joining us. Until next time.